Hello folks, Miss Roll here with our balancing reactions notes. So our learning target for this video is I can balance a chemical reaction. So first of all, why balance a chemical reaction? What's the point in bothering to do this? And first of all, our point is the conservation of mass. We have talked about this before, but it's been a bit. But remember, the matter cannot be created or destroyed, right? It's got to be coming from somewhere and going somewhere else. And we need to reflect this in our chemical reactions. So this means that the same number of atoms need to be on both the product and the reactant sides. Got to have the same number of atoms, okay? So same number of each element on each side. In other words, the same number needs to go in to the reaction as comes out of it. You can kind of think of this like baking a cookie, right? We start off with a certain number of chocolate chips and a certain amount of dough. We mix them all together. We've got our chocolate chip cookies. But in the end, we still have the same amount of chocolate chips and the same amount of dough as went in. Now they're just in cookie form. Okay, same sort of idea going on here. So wrap. This is a tool to balance our chemical equations. It's not the answer. So make sure that you don't just put the wrap table as your answer. I'll explain what exactly you need for your answer. But it stands for reactants, that's the R. Arrow, right, that's in the middle of our equation. And then products. And I'll explain how to use this all in an example in just a minute. So our steps. Number one is to list the atoms in the equation. So look at what elements we have. Conveniently, it's the same elements on both sides, so you can look at either side to list them. But then you need to count the atoms on the reactant side, so how many of each element. Then you need to count the atoms on the product side. Again, how many of each element. And then you need to change the big numbers on your equation to balance it. And this will make a little bit more sense once we start looking at a wrap table through an example. But those are our 4 steps to balancing our chemical equations. All right, so here's an example, and I'm going to quick switch what my screen looks like so we can go through it. All right, so I believe in your notes, your wrap table is already set up, but you can always easily draw one yourself. So I already sort of drew mine out. But now I'm going to get started with step 1, right? Step 1 was to list our elements. So I'm going to just look on the left side, the reactant side, and look for all of the elements that I see. So I see Al, that's one element. I know it's one because it's a capital then a lowercase. I see Fe, same deal. And I see N. All right, and then I'm at my arrow, so that's my entire reactant side. So I know that I've listed all of the elements that are going to be involved. Okay, so I've listed them in that center section under the arrow. And now step 2 is to count the number of atoms of each element on the reactant side. So I see Al, it does not have a big number or a little, so it's going to just be 1. Fe has a little 3 next to it, so I'm going to have 3 of those. N has a little 2, so I'm going to have 2, and that's my entire reactant side. Now I go over here, and I look at the product side. Now what's important here is that the order of the elements might not be the same as they were on the reactant side, so I got to make sure I'm looking for each element. So I'm going to start with Al. I see Al's right here. There's no little number, so it's just going to be 1. Now I'm looking for Fe. It's over here on the end. Okay, no little number. Just a 1. And then finally, I'm looking for N. It's right here with Al. Again, no little number. So that's just going to be 1. Okay? This is the easy part. This is getting your whole wrap table set up. Now, I need to change the big numbers to balance my equation. What big numbers are we talking about? Well, that's where these blanks you see come in. So you have these blanks in front of each of our compounds or elements. That is where I can put numbers to change how many of each atom I have. Okay? I can't just like go over here and say, nope, this isn't 1, it's 3, and I'm done. No, I got to change something up here to make that happen. That's the only way to do it. Okay? Got to change those big numbers in the actual equation. So I had 1 Fe, gotta put that back. So now I'm gonna go ahead and do that, okay? And I just start at the top of my list and I look for what's not balanced. Well, if I'm looking right now, Al has 1 on the reactants and 1 on the products, so it's balanced. Fe has 3 on the reactants, but only 1 on the products. Okay, so now I know I need to do something over here to my product side. I can't make a number go down, right? Because I don't have any big numbers in front to get rid of. So I have to make my product side go up. So if I look, I find Fe, it does not have any little numbers. So basically whatever I put in front is going to be how many Fe are in the product side. So when I put a 3 here, right? 3 out front times my 1, the little number, right? Since I don't have a little number, it's basically the same as it being a 1. 3 times 1 is going to give me 3 Fe's. So notice I had to put the big number in the equation first, then I can change it in my wrap table. Okay, it does not go in the other direction. All right, so Al is balanced, Fe is balanced. Now that I've put this 3 here, I always want to double check, were there any other elements that big number is going to change? In this case, nope, it just changed the Fe, so that I am good to go. I'm going to go ahead and erase my little underline here if I can. Good to go there, and I'm going to move on to my next element. So now I have N, and I notice that N has 2 on the reactants and only 1 on the products. So again, I'm going to need to change something on the product side. And since, again, it doesn't have a little number, if I put a 2 out front, 2 times 1 was going to give me 2 nitrogen. Okay? But notice this 2 is for this whole compound, right? It multiplies the whole compound. So I didn't only change N, I also changed Al. So you got to make sure that you also count that, right? 2 times 1 gave me 2 Als. Very important we don't miss that. That's like the number 1 mistake that happens. So now I can check my list again. Start at the top, Al, not balanced. I have 1 on the reactants and 2 on the products. So now I'm going to find my Al on the reactant side, which is right here. And again, since no little number, I can just put a 2 out front. That gives me 2 Al. Okay. And I look, there's nothing else in that compound, no other elements. So that means that this is balanced. Okay. So I have now balanced my equation. You can always double check by recounting with the big numbers you've put there, you know, erasing everything on your wrap table to make sure it makes sense. But this is our correct answer. Now I said before, our wrap table is not the answer, right? What is the answer? The equation. Okay, this equation I've circled up here. That's the answer. The wrap table is just a tool to help you get there. So 2Al plus Fe3N2 reacts to form 2AlN plus 3Fe. That's our answer. Hope this makes sense. Go to the next video to see more examples of me balancing reactions because practice makes perfect. Remember, questions are a great way to learn, and I hope you have a fabulous day.